Hello friends and welcome at my channel. Let's talk tonight about Arccos cosine. It's kind of similar to the last video about Arccos sine, but it's slightly different and the derivative of this function is also slightly different. So first of all, let us define where we want to invert the cosine. As you remember, the graph looks like that. So we start at cosine of 0 is 1 if you remember, and we go like that. All right, so at pi divided by 2, we are having the value of 0. At pi, we are getting the value of -1. Okay, so that means if we have f, which goes from 0 to pi, well, this is the only interval where the function is supposed to be invertible. Otherwise, if you see immediately after that, let me change the color, we're gonna take the same values that we previously had, and the same is also happening here. You see we're going down, which means we're going to be repeating at some point or everywhere besides the highest point at 0, 1. So this is the function which is mapping the interval 0 to pi onto -1 and 1. All right, and so the only the inverse function is invertible. The inverse function is defined by Arccos cosine, and it inverts or interchanges the domain and the range. So f to the power of -1 is taking -1, 1 and brings it on 0 pi backwards. All right, so let's see. What is cosine of 0 is 1, so arc cosine of 1 should be 0. I explained it in the last video. Pi divided by 2 is approximately 1.57 or something, so we are somewhere here, and we are having the value of 0. Well, cosine of pi divided by 2 is 0. That means arc cosine of 0 is giving you pi divided by 2. So, and this is slightly higher than 1, so we're somewhere here. All right, and also we have cosine of pi equals to -1. That means arc cosine of -1 is equal to pi. So -1 is somewhere here, and pi would be somewhere there. Somewhere here. All right. So how can we plot it? Well, obviously we should be symmetric as well, considering the identity function. So let's see. Got this one, and it's gonna be something. No, that was all right. And we're gonna do something like that. That's symmetric? Well, not quite. Let me try to do it maybe from the other side. Okay. I think I should be doing better with my properties in drawing functions. So at 1 we're in 0. I'm kind of making a circle, something like that, and we go up. Okay. Okay, this is an Arccos cosine. As you can see, once again, we are never having an infinite slope or something, so the function is nice and differentiable. So we can produce its the derivative of inverse function. We remember if f of x is equal to the cosine of x, the derivative of the cosine was minus sine, and we apply the formula just once again. So f to the power of -1 prime at f of x is equal to 1 divided over f prime of x. assuming of course f prime of x is not 0, so everywhere it is 0 we should just take it out. Okay, so arc cosine prime at a cosine of x is equal to 1 divided over, well, what is the prime? This is minus sine of x. And as you can see, we can bring the minus also in front of the fraction. That's nice. And now we are just rewriting it as square root of 1 minus cosine squared of x. That's the point. And now, so what we have now is arc cosine prime of cosine of x is minus 1 divided over the square root 1 minus cosine squared of x. And now if I'm taking z as the cosine of x, what do I have here? I have arc cosine prime of z is equal to minus 1 divided over square root of minus 1 minus z squared. And that's the story. Thanks for watching. Tomorrow I'll be explaining Arccos tangent, obviously. See you guys. Thanks.